All right, let's continue where we left off. Let's go ahead. If you need to, pause the video and get the prime factorization on your own and see if you can do that real quick. I am going to go ahead and do it as well. For 125 and 75. 125 is 5 times 25. 25 is 5 times 5, just doing a prime factor tree. And so that means that 125 has a factorization of 5 times 5 times 5. 75 has, let's see, I always think of like 75 in quarters. That's 3/4, so 3 times 25. And then 25 can be factored down further into 5 times 5. So the prime factorization of that number is 3 times 5 times 5. So now when I'm looking for first the greatest common factor, everything that they have in common, well, they have a couple of 5s in common, don't they? So 5 times 5 or 5 squared, which is 25, and that's the greatest common factor of 125 and 75. For the least common multiple, I'll make another list. Let's see, I'm going to take the 125. It is 5 times 5 times 5, or I can write it as 5 cubed. And then 75 is 3 times 5 times 5. Now remember, for the least common multiple, you take and write down every number you see in either list. I see a 3 and a 5. Those are the only numbers I see used. Now find the largest number of 3s. Well, it only occurs once in one of the numbers, so that's all I'm going to use there. For the 5, you look at your two lists and you say, well, what is the most number of times that 5 occurs in any of the numbers? Well, it occurs 3 times in the first number, so 3 is going to be our exponent there. And when I multiply them together, I get 375 as my least common multiple. Let's go ahead and take a look at number 6. The principal of Valley Elementary School, and again, if ever you feel like it's going too fast, just pause it, take it in, and then continue. The principal of Valley Elementary School wants to divide each of 3 fourth grade classes into small same-size groups. If the classes have 18, 24, and 36 students, what is the largest group size? Well, that's going to be a greatest common factor. So I'm going to do 18, 24, and 36 and break them down into our prime factorization so I can find out what the greatest common factor will be. For 18, do a better job there. That's greatest common factor of 18, 24, and 36. So because those are the number of students you have, like what group size can you break them all up into? And so that's what our greatest common factor will show here. 18 has a prime factorization, well, it factors into 2 times 9. 9 factors into 3 times 3. So 18 has a prime factorization of 2 times 3 times 3. 24 can be factored into 4 times 6. 4 can be broken down further into 2 times 2, and 6 into 2 times 3. And again, pause the video if you want to work on this ahead of time a little bit and see if you can come up with the prime factorization yourself. 2 times 2 times 2 times 3 is the prime factorization of 24. And for 36, I see 6 times 6 there. 6 is 2 times 3, 2 times 3. Okay, so for 36, the prime factorization is 2 times, I see 2 2s. I like to put them in order, right? When you see the ends of the branches, I put them in order. 2 times 2 times 3 times 3. So if I'm looking for the greatest common factor, It's the number that they both have, a number that they all have in common. And it's going to be the largest I can come up with. Well, they all have a 2 in common. And they all have 1 3 in common. See, there's not any more 2s or 3s in common in all of them. So 2 times 3 is going to make up our greatest common factor of 6. So the classes can be broken down into groups of 6 students. And finally, number 7. Cinemark 1 and 2 start their movies at 7 p.m. A movie at Cinemark 1 takes 75 minutes, while a movie at Cinemark 2 takes 90 minutes. If the shows run continuously, when do they have one that starts at the same time? This is similar to when are they both going to be off on the same night in number 3. So we are going to be looking for the least common multiple. When will they have a time in common, right? Least common multiple. So I'm going to break 75 and 90 into prime factors. 75 we saw earlier, and it was 3 times 25 and 5 times 5. So I'm going to write the prime factorization of 75 down, 3 times 5 times 5. For 90, I see 9 times 10, and 9 is 3 times 3. 10 will be 2 times 5. So here the prime factor, there is the prime factorization of 90. I'm going to write it down, and I'm going to put the numbers in order, easier to look at. 2 times 3 times 3 times 5. Now remember, for the least common multiple of 75 and 90, I start off by writing down all of the numbers I see in every list. I see 2s, 3s, and 5s. And I don't know why I put commas on there. Because we're going to multiply in the end, aren't we? Okay. Now, what is the largest number of 2s you see in any list? I see 1, 2. Then you do it for the 3. What is the largest number of 3s that you see in either list? I see 2 3s. What is the largest number of 5s you see in either list? I see 2 5s. So the prime factorization is going to be 2 times 3 squared. The least common multiple will be 2 times 3 squared times 5 squared. When I multiply that together, that's going to be 450 minutes. Woo! Okay, 450 minutes. That is going to be, how many hours is that? Every 60 minutes is 1 hour. I'm curious as to, well, they ask, when will they start at the same time again? Let's see. That's going to be going to it 7 times 60 is 420. Subtract. Okay, so 7 hours and 30 minutes later after they start. So I've got to figure this out. If they started at 7 p.m., I've got to add 7 hours and 30 minutes to that. What time will that be? Well, let's start from 7 p.m. to midnight. I'm going to kind of put it on a little chart here. From 7 p.m. to midnight, that's 5 hours, right? I need more. I need 2 more hours. So that's going to be 2 a.m. and then another half hour. So that's going to be at 2:30 a.m. All right. And we're finished with note 6. I'll see you in note 7.